Yeah, okay. I will be starting my session. Mostly it will be interactive sessions. If you have any doubts, you can raise me at the time. Okay. The point, if you raise it, I can explain you and clear. Then I will go for the next. If you have any doubts, uh, you don't want to mute it. If needed, you can join with me. Akhilesh, because this is like a one-to-one only. This is a demo session. So first, I would like to clear with you. Okay. So. What do you think about big data and what is the use of that and why the business is moving to the big data? Any idea, Akhilesh? Do you have any idea about that? No, I cannot hear. Hello. Okay, something has happened. Okay, I don't like to go deny everything. Okay, this is a basic demonstrations only, so I would like to explain everything. What is the big data concept? Then we will go further deeper by next days. I think I cannot hear your voice. Okay. Okay, so big data. Big data means collections of record with all types of data can handle in a single process. If needed, we can implement all the types. Yeah, please. Yeah, I can hear now. Yeah, I can hear now. Hello, hello. Okay, Akhilesh, no issues. I will be continuing myself. It's very mild voice. Okay, so that is big data. So we will be going to handle the large data set with all types of data. So whatever the data, it will become only by three types: structured, unstructured, semi-structured. So those three we can implement with our tool and making our operation for our business perspective. So that is the users we are going for the big data concept here. So this is the big data meanings. So collections of large data set that cannot be processed by using traditional computing. That is also. I'll tell you what is traditional computing. Um, mm, without interactive session, okay, I will be continuing. So in Hadoop, big data is a concept. Hadoop is a framework tool. So big data methodology, we are going to work with Hadoop framework. In Hadoop framework, storage layer and processing layer, two types of layer will be available. In storage layer, we will be followed to store all the data based on distributed file system. In processing layer, we will be going to retrieve the data based on Google MapReduce algorithm. That is the main use of that. This is the difference between the traditional approach and Google solutions. So normally we are going to approach our data based on the user in centralized system, and whatever the data we have, that will be stored in relational databases only. So this is the only structure format we are working before. So whatever the data that will be stored in relational databases, and we are going to shooting our query based on SQL. then fetching out the data and making our operation and producing the output. Like that we have performed before. But Google have provided some different solution. So that means is same centralized system, we are going to approach our data based on commodity hardware. That is the main differences. So what is commodity hardware means? Our local kind of hardware is called commodity hardware. For example, our laptop or mobiles, these all is a kind of commodity hardware. Based on that, if you are going to approach our business, that will be very much good and very less cost effective will be happen with the business. And some failures, if anything happen with the relational databases, we in the server we cannot continue our business. But in commodity hardware we can continue with the rest of the commodity hardware products. And in such cases, if any failure will happen, the cost also very low. So that is the main reason we are entering to the commodity hardware. And commodity hardware, one more advantage is the same kind of distributed file system concept will be applied into the multiple hardware at the same time. We have multiple cores making our operation, but in centralized system based on the relational databases in the server, it will be followed by single system only. So network delay, drawbacks, everything will happen traditional approaches. That's the reason Google will be moving to the commodity hardware approaches. In Google, Hadoop also will be follow the same because this Hadoop is copied from Google solutions only. Okay, any doubts? Akhilesh, any doubts do you have? Can I go next? Hello, can you hear? Hello, Akhilesh, can you please confirm if it is okay? Then I will be proceed because we could not interact. So once you confirm with the slide, then I will go to explain for the next slides. Can I go next? Yes, I cannot listen your voice. Okay, no problem. You can chat me if you have any doubts. Okay. Okay, I'll go. I'll go for the next slide. This is a brief history. So, in big data brief, when it was started and till now, what are the improvements it was happened like that. It's like a brief history. The Hadoop was introduced by Doc Cutting. He is working for the Natchez before the project with the Google team. Google will be released on white paper in 2003 and 4 that is called the GFS and MapReduce paper. So based on that, Hadoop was created in Natch project itself. But Google will doing that same this project for their own purpose. But based on this concept, it was introduced in the business perspective. And 2006, it was released for the only for the business perspectives with the name of Hadoop. So more or less, it will be same with the Google concept only. We'll be know about the Google architecture as well as HDFS architecture in the later. So this is the flow. Okay. So Hadoop in 2008 it was going to join with Apache project, and 2008 Cloudera was introduced. So Cloudera company, uh, yeah, okay. So docketing going to join in Cloudera in 2009. After that, the Cloudera is a one of distributions will be followed by Hadoop. As well as we have three distribution will be available. One is Cloudera, next one is Hortonworks, third one is MapR. So Cloudera is very much famous because the inventor is joined with the Cloudera company right now, and he is working with that part. And 2009, it was introduced for the commercial distribution with the open source, and Hadoop will be implementing with multiple ecosystems. After that, 2010, Hive being a HPS like a lot of ecosystems will be introduced, and it was famous one by one. This is the Google architecture. Okay, so in Google architecture, you can see this one GFS master will be available. GFS master will be controlling all the slaves. The same kind of approach will be followed in next. So whatever the request will be raised from the GF client, that will be going to check with the master. The master will be allocating some work, some tasks to the slaves. So the same kind of operation we are going to approach with uh, commodity hardware in Hadoop. Here you can see this one. The master is called here as a name node. So name node going to interact with the data node. So whatever the request will be raised from the client, it's going, yeah, yeah. The client will be, whatever the request will be raised from the client, it's going to check with the name node. Name node have their own metadata where the data will be available for the entire data nodes. So once the metadata information we all get from that name node, then we are going to find out the operation with the data nodes. So based on the replication factors and data block sizes, we are implementing some advanced optimization techniques in Hadoop. So that will be very much useful to us. Later part in that the architecture discussion, I will explain you what are the improvements we will be introduced with the Hadoop. Okay. Um, do you know any doubts till now? You have any doubts now? Distribution. Distribution means equally distributing the data. Just a second, I will show it to you. Here is the distributions. Normal traditional approach, whatever the request we are going to send, that will be going to store in the relational databases only. So for example, normal SQL query, if you shoot your query, it's going to be followed in the queue mode. So step by step, uh, if multiple user can interact the data with the relational database that are in queue only. So once it was triggered, then only we will be going to execute the next query. Like that, it will be performing. But in distributed file system, at the same time, we can execute all the query into our file system concept. For example, that's the reason we are introduced for the replication factor also. Here you can see this one. We are introduced with the three commodity hardware. So here, based on the replication factor, the same data will be replicated in another commodity hardware also. We can get the data immediately. So without any delay, without any network latency, we are approaching our data in that immediate factor. And Hadoop we are introduced with the read-only operations. Um, so in the architecture part, I will explain you what is the uses of that and the distribution, how it will be working, everything. In demo session, this is enough for you. I don't like to confuse you more in that Hadoop projects. One second. So Here you can see this one. It's a scale up and scale up project. So normal relational database is followed by the scale up only. So all the requests will be going to set in the our queue and followed by the single hardware. So what will be happen? The request will be executed one by one only. Whatever we have the multiple CPU size very big, then we even then we cannot execute entirely. But in scale-out process, the request will be split at multiple ways. That is the use of distribution factor. This is for the sample example. Data distributed equally will be distributed. So node A have the two user kind of input file. Let's say for the example will be considered. So the file will be stored in node A as well as node B and node D. Based on the data distribution, if you are going to approach our data in node A, at the same, if any other people going to approach the same data, we will be going to interact with node B and node D. So without any delays, we can retrieve the data. That is the main use of distribution, as well as parallelization is another one kind of concept. Yeah. So parallelization concept also will be introduced in big data. Uh, that will be controlled by the Spark optimization technique. So you, while you're studying about the ecosystem about the Spark, you know what is the use of parallelizations. Okay. Now you are clear with the distribution. Can you please confirm? Yeah, okay. Simple example for the distribution, I will giving you for playing cards, rummy cards we are playing, right? So total 52 cards will be available. So that will not be equally distributed. It will be shuffled. We will be providing to the multiple people. So multiple people going to approach the data and reshuffling the data and giving back to us. At the time, the cards will be distributed to the multiple people and fetching. Sorry, um, and they will be sorted and final sorted I will be doing myself. So that also one kind of distribution, but that will be followed by distribution comes with parallelizations. Later we will discuss what is the difference between the distribution and parallelization, but these are for the example for your easy understanding. So this is we are going to work with our project into the HDFS architecture followed by that. So here we are going to study what is name node and data node and what is the rack server, what is the block size and how the task will be split and everything will be discussed later. Um, Now this is enough. Okay, this is the history of databases. So in 1973, we are introduced with the network databases only. We are going to approach our data based on the network databases. After that, Boyce code normalization from BCNF, we know relational databases very well. That was introduced. So based on that, our project will be moving to the relational databases. After that, it was introduced for the distributed databases. That's the distributed databases will be followed in after 1998 only. So, which means we are going to approach the data in the same manner with multiple user at the same time. So that is the use of distributed databases and transactions. Now we are entered into the modern databases and object-oriented databases. Hello. So that right now we are entered into the object-oriented model databases. Uh, which means we are going to approach our data not only for the structure, so we are going to approach our data for unstructured also. So here we are following some unstructured format data like video files, audio files, um, images, everything is an unstructured format, but our business going to approach our data based on the unstructured databases also. For example, Facebook and Twitter, they are following their data based on the unstructured format. Um, Whenever they need it, immediately they can share and retrieve the data in uh, their tools. So within a short time, we are going to approach the data. That's an important. So even for the structure as well as unstructured both, we are going to approach with our business to getting the better benefit. So that is the reason until we are moving. Here you can see this one, the differences between the kilobyte to yottabyte. Right now we enter into the terabyte operations only, but our business followed to yottabyte and still more. And here you can see the comparison after 1990s, the unstructured format will be introduced a lot. So our business entirely moving not only for the structure, it moving for the unstructured databases also. So the unstructured databases will be giving more input, sorry, more details. Then our business will be giving, getting some clarity with that only. That's the reason we are moving entirely to that. For example, if you're going for any hotels or any somewhere, if you have mentioned anything about that particular business, you'll be to your people, that will be followed by text or somewhere. So that will be followed into the unstructured format. So from the text, we are converted into the structured format. What you are discuss about that, like a keyword we will be providing. So in Twitter, top trends will be followed like that one is that hashtag and keyword will be identify how many people will be discussing the same concept. Like that, it will be making some algorithm and giving to us. Like that, it will be followed in the backend. Okay, that is the use of unstructured formats. So we are know very well about the unstructured format in our business. Um, then structure format, but the structure format also is very important because that will be followed by the proper data. Rest of that we need to cleaning and making our operation with that, and that's the differences. So day by day increasing ratio also will be raised in the unstructured format very much. Any doubts? Akhilesh, any doubts do you have? This is the four V's we are introduced in big data. So big data will be definitely satisfying these four V's. First one is volume, variety, veracity, and veracity. These four only. So this will be a basic four will be satisfied in the big data concept. So this is an important. Uh, Raise me if any doubts. Okay. So volume. So we can handle the large data of volume with big data concept that will be satisfied. That will be uh, whatever the sizes we can implement with our project and making some output. Next, variety. So the types of data is called a variety of data. So those data will have only three types. One is structure, second one is unstructured, third one is semi-structured. So those three data we can handle in the our big data concept as we have discussed before itself. And next one is velocity. Velocity means accessing the data. For example, normal relational database, we will be following the data based on some indexing concept. So whenever we need it based on the indexing, we can identify the data in particular primary key ID and find out. That is a way of approaches in relational databases. But here we are using for some MapReduce concept. So the MapReduce concept helps to identify the data into the big data storage layer and find it out. So velocity is followed by the processing layer. Volume and variety will be followed by SD Hadoop layer. Yeah, storage layer. Hello, any doubts? Okay, can I go for the veracity? So, okay, veracity means that's a like an uncleansed data or untrusted data, which means that will be a incorrect or duplication data. So we have the data, but the data will be incorrect or invalid data or duplicated data, whatever. We are identifying the data and we can skip the data and making our operation. So bad records, purge records, everything we can making our operations with big data concept. For example, for any mobile number, we can take it out. The same mobile number will be stored at twice in the different name manner. But if you're going to approach our data based on the same mobile number, the business, sorry, not only business, we will be confused. So same kind of situation will be happen in that business also. So we need to cleaning our data before proceeding. So that is called veracity. Big data con helps to making that operation with veracity also. So this is the four will be definitely satisfied in big data concept. Volume is large data set. Variety, types of data, three types of data only. Whatever the data we will be received, that will be followed in three types of data only. Next, velocity, that we are introduced for the MapReduce processing layer concept, and veracity will be used for incorrect, invalid, and unwanted data, everything. So these four we can satisfy. Any doubts? Okay, so this is a scale up and scalar. Already we have seen this in the distribution. Here the difference between the commodity and why we are introduced. That is the use of this scale up and scale out. Here the scale up means the entire data will be stored in single hardware only. So in such cases, if anything failure based on the fault tolerance or uh, uh, partition tolerance, we cannot making our operation with that. But in if we are going with scale out, we will be splitting our data. So if any failure will happen, we can making our operation with the rest of that commodity hardware. So that is the use of commodity hardware was introduced in the scale out operations. So everything will be very less and making our operation with that. That is the main differences. And cost also very low in such cases. If any hard disk or rack failure in that main server, we are going to replace that very huge of cost. But in the scale out process, if any server or hardware is failure, that will be very less only will be happen. Example for laptop is considered as a commodity hardware. Next one is replication factor. So replication factor is a kind of way of approaching our data in HDFS. So same data will be replicated in multiple nodes. A node means like a cluster. I would like to explain you what is cluster. So okay, this is the cluster. Okay, one should be a master, rest of the slave. So this should be a slave. So we are going to interact our data with cluster mode only. So this entire model is cluster. So one master, list of four will be acting as a slave node. Example simply for your understanding is like a laptop only. So one laptop will be working as a master laptop and rest of that will be performing as a slave. So this is a commodity hardware approaches. But the normal traditional approaches we will be followed by that one master as a, like a laptop is a user and followed by one big servers. 。 So what are the requests will be raised from the client that going to interact with our server and getting out back. So like that it was performed before. We are not introducing here server, instead of that we introduce for the normal commodity hardware. That is the differences. Any doubts?
Hello.
Yeah, now I can hear.
Hello.
Yeah, please.
Can you hear me now?
Yeah, now I can hear clearly.
Hello. No. Now I don't hear your voice.
Very bad luck.
Okay, let me.
Hello. Now?
Yeah, I can hear your voice. Are you able to hear my voice now?
Yeah, I can.
Oh my God, thank you so much.
Yeah, okay.
So, yeah, I'm following your lecture.
Yeah, okay.
Yeah, we are going at a very high level, so I don't have any questions as of now.
No,
So,
this is the base, okay? This is the basics only we have discussed. This is not a
yeah.
high level.
Yeah, but I mean, like, you're going on I mean, like, you're just going, like, you're just covering the outlines of it. So, I know, I mean, like, yeah, I understand what you're doing right now. So, yeah, that's good for me.
Okay.
Um, yep, you can go ahead. Now I can hear you. I can ask you some questions. Now it's good.
Yeah, okay. Till now, do you have any questions? Any doubts?
Not really. Only thing I did not understand is like I heard that big data is like three V's: volume, velocity, and variety. I know all those three, but what was that veracity like? Is it like a what does it mean? I did not really get that.
Actually, normal volume and variety and velocity, those will be followed by the layers in the storage layer as well as in processing layer. So volume and variety will be followed in the storage layer itself. In velocity, we'll be using the MapReduce concept in the processing layer. That is enough. Okay. So veracity means that is untrusted or unclaimed or incorrect data or invalid data, whatever. We have the data in storage layer, right? We are going to approach our data in the
Mhm.
storage layer, but in that part, what will be happen? We are not clear with that. So what is the data? First, we
Okay.
need to know, right? Then only we will be
Yep.
doing our
For
operation.
example,
That is,
for example,
I'm saying, for
yeah. For,
example, you have your contact, right? In that contact,
mm-hmm.
name number you will be stored in different name. Like your father name is, you will be mentioned with your father name or father or dad. Like that, you can store the same name. So what will be happen? The
Oh,
same name will be duplicated, right?
okay.
So that is the
Okay.
veracity. So if I am going to find that my contact detail based on this approaches, it will be populating you three duplication data. So what will be happen? If the same cases will be happen in the business, our data will be incorrect. Correct. So we need to clean our
Yep.
data. Then only we are going to approach on that. That is the reason veracity. That is possible in that ecosystem operation. We can split the data. So
Okay.
only for the cleaned data we are going to approach it. If we have a duplication data, if we're going to approach our data, then the business will not be giving a better exact output to us. So
Okay. Okay.
volume and variety will be going for the storage layer. A velocity will be approached with processing layer, as well as the veracity also we are going to approach with the processing layer, but in different ecosystem manners. That is the differences. Now you are clear?
Okay. Yep.
Mm.
Good.
So this is okay. So scale up and scale out differences. Replication factor we have discussed, and block size we are introduced is 128 MB in Hadoop 2.
But sorry, I mean, like, I have a question here.
Yeah,
For replication factor, the default value is 3.
yeah,
Um, so, in real time, like, if we are
yes,
going to some medical insurance client or something like that,
yeah.
what would be the real time replication factor? Like, how much do they set it to?
That is actually you said is correct. That is a default replication is 3. So what will be happen if we have a default replication 3 means normal
It
data
will be
will be
replicated on
replicated threes, right? Type for
it
example.
will be replicated on 3 data nodes.
Yes, okay. So even size also will be very high, right? So for example, 1 GB of data we have. If 1 GB of data we
Mm-hmm.
are going to approach with replication factor
Mm-hmm.
3, then our cluster will be taking 3 GB of data, right?
Right.
So in
Mm-hmm.
storage manner, we will be losing 2 GB more for storing the data.
Right.
Okay, so 3 GB will be occupied in HDFS cluster. That will be taking some more spaces, right?
Mm-hmm.
So that's the reason we introduced some different types of file format. That's a science data science file format like ORC, RC, sequence files, Avro, Pocket, like that, the file format. So what it will be doing, the 1 GB of data will be compressed, and we are introduced a lot of the compression also. Without compression, I'm saying. So the 1 GB of data, if you're going to approach with data science file format, it convert into the 200 MB of sizes only. So 200 MB of sizes
Mm-hmm.
into 3 replication factor, total sizes 600 MB.
600.
So this is
Mm-hmm.
to compare very less than normal 1 GB of data. To compare with
Right.
normal 1 GB of data, this is very less only,
Right.
and will have multiples of 3. So this is the
Okay.
one of the benefit.
Okay. But does everyone use this method?
Yes,
Avro and data science
exactly.
method?
Definitely they will be using in the project, definitely with the data science file format only. That
Okay.
will
Okay.
the reason behind this one, and performances, because in the data
Mm-hmm.
science file format will be help for performances also.
Yeah, if the file size is small, it is easy to retrieve it, right?
Yeah, it will be immediately retrieve the data into the memory and making our operation much faster. So that is also
Okay.
one of the
Okay.
things. Okay.
Okay.
So
Okay.
default replication manager is 3 only in project itself. If needed, we can increase.
Okay. Okay.
Okay, can I
Okay.
go next?
I got it. Yep. Yep. Go ahead, please. Don't mind. I mean, like one of my roommates is watching some movie, so.
No problem. Okay, without interactive session, that I plan. That's
Yeah,
like,
even I was like, yeah, I was like, I mean, like, I cannot ask you questions, and
yeah,
because
without
this
it.
session is really, these sessions are really very important for me because I'm about to start a project in big data, so I
Yes,
would
I
need,
know that. Yes, I know that. And without interactive, that's like a memorized. So that will not be helping you. And even
right,
me
right.
also is not interested. That's the reason I informed you. Come for the interactive sessions.
And also one more question I have is like, are you recording this session?
Yes, sir, I'm recording right now.
Okay, sure. Thank you so much.
Yeah, okay. Okay, this is the next way.
Yep, yep.
This is the request. Okay, so whatever the request we have received, that will be going to work with a name node and data node. Deeper session will be discussed what is the name node, data node, everything. This is for the request operation, how it will be performing. Okay, so client will be send the request to that name node. Name node going to interact with our data node. So name node having the metadata entirely, it's going to check where the data exactly will be available. So once it has been identified, the MapReduce concept, the processing layer will be working. So these are the data that request will be converted as a job here. That will be followed by job tracker Hadoop 1.0. So the request
Mm-hmm,
will be
mm-hmm.
the request, whatever the request will be raised, the data node will be controlled based on the task. Multiple tasks will be introduced. The task will be moving here to for the easy comparison for the HDFS as well as performing with the job tracker. So the task will be moving here, that will be controlled in the job tracker. Multiple tasks will be worked with data node. This is the block.
Mm-hmm.
Like that it will be performing. Okay. So for
Yep.
example, select star from a table A, join with table B. So here the request from the client is only one query will be passed to our SDFS. So name node identified where the table A data will be available, table B data will be available. Based on the task will be split. So job tracker will be created to follow the query, and the multiple tasks will be split on the data node. So task 1 and task 2 will be going to use for the data node to identify the table A and as well as table B data. After that, going to interact with join operations. So three tasks on this.
So basically here what we are doing is First, when we are joining two tables, we are looking for the two tables through name node and data nodes, right? Name node has the
Map,
metadata where those two
yeah,
tables
yeah,
reside.
yes, exactly.
Then we are going to data node and finding those two tables.
Yes,
And
that
task
like
tracker is actually performing that joining process, and job tracker is actually
it identifies the
checking
entire
on these task
yeah,
trackers.
yeah, exactly.
So processing is happening in with the help of job tracker and task tracker, and
Yes,
storage is with name node and data node.
yes, exactly. That is correct. That is the reason in the
Okay,
client
okay, got
request I have split it into two. Storage layer followed by HDFS, processing layer followed by MapReduce concept. Here you can see the
nice, nice. Okay,
that
yep.
is an important. This is an storage layer. This will be followed by
Mm-hmm.
processing layer. Okay,
Mm-hmm.
We can
Yep.
split it simply.
Yes. Okay.
Okay, can I go next?
Yep. Sure.
This is a MapReduce for the easy example. So what is MapReduce? For the simple understanding, we have the data. It will be working with the map operation and sliced or transformed into our required format, required modeling. Then reducer
Mm-hmm.
helps to combine all our transformation as our output. So this is a sample example for the burger, how it will be made
Mm-hmm.
based on MapReduce concept. So because
Okay.
a lot of the people will not be understand what is MapReduce, so this is for them in the demo session. I would like to explain you so simply they can understand.
Okay.
So the
Mm-hmm.
same, if going with the MapReduce real way, this is like look like that only. So data node will having the data based on the input key value. The key value can be identified by the map based on the key as well as values. It will be interact with the intermediate values.
Mm-hmm.
So intermediate key value will be going to interact with our reducer based on key as well as intermediate values. The final reducer going to creating the final key and values. This is a way of approaches. Little advanced to compare with previous slides. Okay,
Mm-hmm.
these are all the ecosystem you are going to study here. Data injection tool we have for that Hadoop, Scoop and Flume. So Scoop help for that structured format, Flume help for unstructured format, and whatever the data that will be stored in HDFS only, that will be controlled in Yarn. Yarn will be followed by MapReduce as well as Spark. Is the two kind of ecosystems. We will be later we know what is MapReduce and Spark. Okay, the difference in between that will be Spark will be working in memory operations. That's the main differences between that. Rest of them will be discussed later. Okay, so the data will be injected by scoop and flume operation, and analysis operation will be going work with peak as well as
Where is
high.
this data getting ingested from? Is it coming from an RDBMS machine?
Yeah, that will be help for scope. Only RDBMS data will be interact to Hadoop. That is called that will be followed by scope only. The structured data is only actually it was. Scoop
Okay,
means
so it's
SQL plus Hadoop. That's a short name. So definitely it one way should be
oh,
RDBMS, another way should be a Hadoop. So for
okay,
this is structured format. For unstructured format, we will be used for Flume. So Flume
okay.
helps to interact the data from unstructured format, like that weather or some sensor data, lot of
Instagram,
whatever,
Facebook.
yeah, whatever, Twitter data,
Okay,
whatever the data will be unstructured. That we are going to pull out into that our HDFS. Then we are starting our operation. Once this is the data injection only. Once the data introduced, then we are going to work with data analysis tool like Ping, Hive, Impala like that tool. Okay.
okay,
So
okay,
data exploration we can using to explore the data based on web UI that is called. So that is called a data exploration. So web UI, whatever the data we have, we can identify it here itself. Then workflow is a call to Uzi. It's like our job scheduling operation. So one by one we can execute our job based on that workflow. For example, scope once the job the data was ingested, then we are going to work for data analysis like Pig and Hive. So like the performance operation, we can schedule here one by one operations. Another one is called
Okay.
NoSQL databases. So NoSQL databases we are using for HBase is a column-oriented databases. So how it will be performing with our HDFS like that. These are all ecosystems you are going to study here, except Impala. Impala and Hive both will be same as a SQL kind of query languages ecosystems. But here we are going to study only for Hive, not for Impala. Okay, these are all you are going to
Okay.
study here. Okay,
Mm-hmm.
yeah, clear?
Yep. So will you be covering Spark also?
Yes, yeah, basic Spox, how it will be functioning like that we will be covered.
Okay.
Okay,
Yep.
yeah, okay. This is a job opportunity, so you are in US, so no problem. These are all you know very well. What are the job opportunities you will be getting? So for the simple understanding, so
Yeah.
no problem. Okay,
Yep. Yep.
so this is the demo sessions. That's it. Now you understand what is big data, what is the use of, what is that ecosystem will be available, and what kind of approaches. Everything we have discussed. Do you have any doubts today?
No, but yeah, most of the time I was trying to connect to the microphones so that I
Yeah,
can
we need
talk
to
to you.
ensure
But
that.
yeah,
Okay, that is not a doubt. That's a problem issues. We need to resolve that. Um, but we'll be doing it soon. Okay. Uh, in that study part, you have any
yeah. But
doubts?
one more thing is like, will you be going in depth, like slowly into each concept from tomorrow? Because today it was like too fast. But you said it's a demo, so that's fine.
Actually,
But
with yes, exactly. I know this is a demo session, so that's the reason I can just simply what is what like that only. In the deeper session, we need to know what it is like that. That's an important. So it will be taking
okay,
later only. That's the reason I am asking you for the interactive session only. Okay.
yep.
So
And what
what?
would be the course length, if I may ask you?
What?
What would be the course length? Like
Um,
how many days or
uh, Time duration you're asking.
yes?
Here the study informations, the theory part we will be covered. Basic the command part we will be make it ourselves. Rest of that you need to continue yourself. That we will be providing the commands everything to you. You need to practice. If you have any doubts, you can raise me back. Okay?
Okay,
Because
and
that's your
also will
dependency.
you be
That's I will give you the timings. How long you
providing?
need, and you can study. For example, I know very well if you're going to work with scoop operation, definitely we need 1 day for the practice itself. So I'll give you the 1 day for you. You just practice and get back to me. If any
Okay,
doubt, you
and
can
one
raise
more
me.
thing.
Yeah,
And one more thing is like if I have a, for example, let's say you are saying like you will give the commands, and I need to practice it, right?
yeah,
So when we are talking about practicing it, are we using any cluster or anything? Do you have any cluster that I can
yeah.
use?
Give you not cluster. We are not provided. We have a tool. We'll giving you a standalone mode. We will be install the how to framework in your system and make it out. Okay. And may know what is your
Okay,
RAM size in laptop?
I think well, I'm not sure. I have to check that one.
Check in your
I'll check that and
RAM memory is a must important. With minimum we needed
okay.
for 8 GB RAM, that could be a fine. Otherwise, the performance will be very late. So you
I
only
think
will
8
trouble.
GB, 8 GB will be
Minimum
there. I
is
mean, like
required.
8.
Minimum
Yeah,
requirement.
8. Yeah, it will be more than 8 GB for sure.
Yeah, then okay. Then okay, that's not a problem.
Yeah.
Because the performance, the query performance will be taking delay. In virtual manner, we will be going to approach our data. That's the reason I'm saying before. So.
Yeah. One more thing is like, can we spend some more time on weekends, like couple of hours, like 2 to 3 hours, like morning 1 hour and evening 2 hours or something like that to push
Evening is
this
not
forward?
possible more. So morning 1 hour we will be studying. Okay. Do you want to go with the fast track? Fast track means
I
with
don't know what
1 month,
fast
one and a
track
half.
is.
Yeah. Otherwise, it will be taking 1.5 months or 2 months like that. That's the reason I'm asking you. Okay, we'll schedule
Um,
the timings. No problem. Later we'll be studying on.
yeah, yep, that's fine. And is there anyone in this class except me? Because I'm talking too much. I don't want to disturb. if there is someone in this class.
Yeah, and actually, I'm taking the direct sessions. The people are in front of me only. For you, I'm taking in that
Okay.
online session. So that's the difference. Okay.
Okay. Yep. That's what from my side. I don't have any other questions. I'm good for now.
Okay, I will share this slide to you. Send me your mail ID in my WhatsApp. Okay, that will be help you. Okay.
Okay, that's
Mm,
fine.
yeah. Okay. Can I quit now? And recordings
Yep.
also will
Thank
be
you so
sending
much.
you. Yeah. Okay. Bye.
Thank you. Bye.
Yeah.